Hello viewers, welcome to another section of my tutorial, and I have a problem in AC theory, which is a topic in applied electricity. And it said a voltage is given V of t, which is equal to 230 sine omega t. When applied to a circuit, supplies a current given by the expression I of t, which is equal to 8 cos omega t plus 8 cos the expression omega t plus 60 degrees plus 6 sine the expression omega t plus 30 degrees, then plus 2 sine the expression omega t minus 30 degrees ampere. And it's saying using phase diagram or otherwise, find the amplitude or the maximum value of the current. Then the B part is saying that find the phase angle between the voltage and the current. So let's see how we're going by this question. So from here, what we are expected to find is to find the Vm, or that is the amplitude of this I of t, or that is of the current. The current is a sinusoidal current, but it has different components, but they are all having the same frequency, so they are not harmonic. So what you are going to do is that you have to combine all these, and to combine these we have to express them into x components and the y components. Then after we add the various components, then find the magnitude as well as the direction. That will give us the equivalent or the resultant of all these components. So from here, whenever you have to resolve or find the x and y component of a waveform, make sure that it is in the standard waveform, and the standard waveform of a wave is a sine omega t, something like this. So a sine omega t or a sine omega t plus x. So always it should be sine. That will be the standard of, or the standard waveform expression. So from here, all the cos will be changed to sine, and we know that cos theta is equal to sine theta plus 90 degrees. So to express the first one, that is, we are rewriting it in the standard form, I of t. So I of t is equal to, we have 8 cos omega t, that one is going to be 8 sine omega t plus 90 degrees, plus, for the 8 cos omega t plus 60 degrees, it will change to sine. So we're going to have 8 sine omega t plus 60 degrees, then plus 90 degrees also. Then from here we move to the third waveform, and that one is 6 sine omega t plus 30 degrees. So you're going to have 6 sine omega t plus 30 degrees. It remains the same since it's already in the sine and it's a standard. Then plus the last one, which is 2 sine omega t minus 30 degrees amperes. So now all the components are in the standard sinusoidal waveform expression. So we are left to resolving each component into x and y components. So let me write my x component here, then my y component here. So from here, my x component for the first one is going to be 8 cos 90, then 8 sine 90 degrees to be the y component. For the second one, I'm going to have 8 cos 150 degrees, because 60 plus 90, then 8 sine 150 degrees. Then the third one is going to be 6 sine 30 degrees. Then here is going to be 6 cos, then here is going to be 6 sine 30 degrees. Then the final one will be 2 sine 2 cos negative 30 degrees for the x part, then 2 sine negative 30 degrees for the y part. So this is going to be equal to, cos 90 is 0, so everything will be 0 here. Then 8 cos 150, you punch it into the calculator to get your value, and that is going to give us negative 6.93, or let me leave it in the radical form, so negative 4 root 3, then 6 cos 30, 6 cos 30 will give us 303. Then 2 cos negative 30. 2 cos negative 30 will give us root 3. Then we'll do same for the y component. So we are finding the value for each component after we sum. So sine 90 is 1. So you're going to have 1 multiplying 8. So here will be 8. Then 8 sine 150. 8 sine 150. And that will give us 4. 6 sine 30 will also give us 3. Then 2 sine negative 30 will give us negative 1. Negative 1. So after you find the total x component, then the total y component. So we have to add all this. So you have root 3 plus 3 root 3 plus negative 4 root 3 plus negative 4 root 3 plus 0. So everything will be 0. So here our answer will be 0. Then here we have 8 plus 4, 12. 12 plus 3, that will give us 15. Minus 4, that will give us 14. So from here we have seen that our x and y components are 0 and 14 respectively. So to express this back to the waveform, we are going to have the magnitude of this, that is the amplitude is going to be the magnitude of the x part squared and the y part squared. So this will be equal to 0 squared plus 14 squared. And this is also equal to 14 itself. So that will give us the amplitude of the final waveform. The amplitude of the final waveform. Now let's see for the phase angle. So to find the amplitude, or for the A part, it is answered here. So you say that A amplitude is equal to, so we have to find the amplitude of the current. So it's equal to 14, or let's say 14, the amplitude of the maximum value of the current. Since current, let's add amperes to it as the unit. So you have amplitude to be equal to 14 amperes. Now find the phase angle between the voltage and the current. So we have to find the angle, and you know that tan theta is always equal to the x, sorry, we have tan theta. If you draw, we are going to get the y over the x. When you draw, we realize that the opposite over the adjacent is the y over the x. So our y value was 14 and our x value is 0. So tan theta is equal to 14 over 0. Now what will be theta? Theta is going to be the tan inverse of this expression. And you know that this is going to give us undefined. So tan inverse of this will give us 90. Now let's see if it's true. Tan is the same as cos theta over sin theta. And this should be equal to 14 on 0. We'll cross multiply, and this will be equal to 0 multiplying cos theta equals 14 multiplying sin theta. This will give me 0, which is equal to 14 multiplying sin theta. Now from here, I'm going to divide through. Sorry, we have tan theta to be rather sin theta over cos theta. So tan theta is rather sin theta over cos theta. So that will be equal to 14 over 0. So when you cross multiply, you get 0 multiplying the sin theta rather to be equal to 14 multiplying the cos theta. So you get 0 to be equal to 14 cos theta. Then our cos theta will be equal to 0. So our theta, which is equal to cos inverse of 0, is simply 90 degrees. So we can say that the phase angle between the voltage and the current is going to be equal to 90 degrees. this is the end of my video, and sorry for the simple errors I made. Thanks for watching, and kindly subscribe, like and share to follow as I post similar videos.